Alright, we're back. Time to sort it out once again. Here we have a system problem that is a little bit more complicated than others. We have a modified outwood and we have an angled ramp, no friction on the ramp. So let's call this mass 1, let's call this mass 2, and let's consider forces that would get this block to go up the ramp. Let's consider those to be positive. So again, systems problems, we want to think the acceleration is going to be the net external force on the system divided by the total mass of the system. Now, what are those forces? We have the weight of mass 2. We also have the weight of mass 1, but because we're on an incline, it's not its full weight. It is the component of its weight that is parallel to the incline. So the force from block 2 would want to move the system up the ramp, and then the component of the weight of mass 1 would cause it to move the other way. So that's how we get this expression here, using force gravity parallel. Right, continue with that and plug in for the weight of block 2 and then the component of the weight of block 1. Subtract those two, add the two masses, and the acceleration of our system should be given here. That will help us with the first part. Then we need the tension in the string. For this part, let's focus in on mass number 1. The net force on mass 1 divided by the mass of mass 1 will be equal to the acceleration. So here we have tension up the ramp, we have force gravity parallel down the ramp. Subtract those two, divide by the mass. So plugging in for on the top here, we have, and also we multiply both sides by mass number 1. Then we, wrote tension on the left, and we added over the force gravity parallel to this side. So we get that. So here's an expression for the tension, factor out mass 1, and that formula should solve the problem.